Good morning, my dear student, and welcome to my channel, that is Easy Chemistry by SBG. In last lecture we have completed the theory about the ultraviolet and visible spectroscopy. In this lecture we will solve some examples. Before solving some examples, let us see some terms involved while solving the examples. First is the homoannular diene. The homoannular diene means the cyclic diene having conjugated double bond in the same ring. जैसे कि यहाँ पे जो ये conjugated double bond है ये एक ही रिंग में प्रेजेंट है, इसको हम homoannular dienes बोलते हैं. Second type of the diene is heteroannular diene. जैसे कि cyclic dienes having the conjugated double bonds in the different rings. The one bond is present in one ring and second bond is present in another ring, but they are in the conjugation. Third term is endocyclic double bond. डबल बॉन्ड प्रेजेंट इन द रिंग. जो डबल बॉन्ड रिंग के अंदर प्रेजेंट होता है उसको एंडोसाइक्लिक डबल बॉन्ड बोलते हैं, और जो रिंग एक्सोसाइक्लिक होता है, जो डबल बॉन्ड एक्सोसाइक्लिक होता है मतलब रिंग के बाहर प्रेजेंट होता है, इसको एक्सोसाइक्लिक बोलते हैं. यहाँ पे दिया हुआ है एक्सोसाइक्लिक डबल बॉन्ड. द डबल बॉन्ड इन विच वन ऑफ द डबली बॉन्डेड एटम्स इज अ पार्ट ऑफ अ रिंग सिस्टम. जैसे कि यहाँ पे रिंग ए एंड रिंग बी है. रिंग ए में ये जो एक बॉन्ड है ये एंडोसाइक्लिक है, एंड रिंग के बाहर से जो स्टार्ट हो रहा है इस कार्बन पे ये एंडोसाइक्लिक डबल बॉन्ड है रिंग ए को, तो इसको एंडोसाइक्लिक डबल बॉन्ड बोलते हैं. टू कैलकुलेट द लैम्डा मैक्स वैल्यू और द लैम्डा कैलकुलेटेड वी मस्ट नो द parent value and increment for the different substituents or group present on the ring or the substituent present on the diene. So basic value for the homoannular diene is 253 nanometer. Basic value for homoannular diene is 253 nanometer. Basic value for heteroannular diene is 214 nanometer. And then alkyl substituent or the ring residue attached to the parent diene is equals to 5 nanometer per each alkyl group or each substituent. Double bond extended conjugation means more than 2 double bond. If there is an extended conjugation, then we have to add the 30 nanometer per each conjugation. Exocyclic double bond. If there is a presence of exocyclic double bond, then we have to add the 5 nanometer for each exocyclic double bond. Then polar group. If the polar group is OAC, then no any contribution of the nanometer value. Then second is O alkyl, then 6 nanometer we have to add if the substituent is present. Then if substituents are halide, chloride or bromide, then we have to add the 5 nanometer for the chlorine or bromine, for each chlorine and each bromine. So let us start examples. This is an diene. Now lambda observe wavelength is 319 nanometer. So the basic value for this diene So the basic value is 253 as we have seen already at the top. So the basic lambda value for the diene is 253 nanometer because it is a cyclic, and the homoannular diene it is. Then extra conjugation is present. This is an extra conjugated double bond, so we have to add the extra conjugation value, that is one double bond is extra, that is why we have added the 30 nanometer. So if we see in case of the second ring, that is A and B ring, this B ring having the 2 exocyclic double bond. This one is exocyclic to B and this one double bond is also exocyclic. So the 2 exocyclic double bond, 2 exocyclic double bonds are there. So we have to add 5 into 2 nanometer. So 5 for each exocyclic double bond. Then substituent. There are total, if we consider, then this 1, 2, then 3, here 4, and total 5 substituents or ring residues are present. So each substituents or ring residue contributed by value 5 nanometer. So total are the 5 substituents. So 5 substituent into 5 for each substituents, and they becomes 25 nanometer. If we calculate it, then we get the lambda calculated is equals to 319 nanometer. So it is an exact to the observed value. Lambda calculated is equal to 319 nanometer and observed is also 319 nanometer. Let us see the second example of the diene. Now it is an acyclic diene. So the value, basic lambda max for the acyclic diene is 214 nanometer. So the basic lambda value is equal to 214 nanometer for the acyclic diene. Then this one double bond is not conjugated. If we consider this bond and this second bond, they are in conjugation, but this double bond is not in conjugated. So there is no extra conjugation, only we have to add the substituents, and there is only one substituent we have to consider. This one is the substituent because no any substituent other than that, and substituent is only one. So we have to add the 5 nanometer, and total will be the 219 nanometer. So lambda calculated is equal to 219 nanometer, and it is approx to the lambda observed wavelength, and the calculated wavelength must be matched. Plus minus 1 nanometer will be acceptable. So this will be the lambda max 219 nanometer for this diene. So in next lecture we will solve the more example. So if you like my video, please share, subscribe and press the bell icon, so whenever I add the new video you will get the notification. Thank you.